Hi, this is a short video on permutation and combinations. So if you're already good with this topic, I wouldn't worry too much about this video. You can check out the lecture slides and just skim through it, go through it and see if there's any part which you don't understand. And if you do, then you can watch the relevant sections in the video. But really otherwise, you can skip this video if you're already good with the topic. We need to talk about permutation and combinations because we need that when we start talking about the search space. So the search space is just the set of all possible solutions. And when we're doing brute force, we're going to go through this set, right? We're going to look at all possible solutions and we check out which one's the right one. So to generate this set, you have to use permutation and combinations, which is why this video is here. Make sure you know about it. Of course, you can always go online, go search for a refresher on this somewhere. You can also go to the textbook, Appendix C. They have a section about permutation and combination as well. But yeah, otherwise, you can also watch this video. We'll see how we go. Hopefully, it's not too hard. So starting with something very simple, this is what we call the rule of sum. If you want to choose one element from one or more disjoint sets, then the number of ways to do that is just the sum of the cardinalities of the set. So if you want to make a number plate, for example, you can either choose a number or a letter. How many choices do you have? Well, there are 10 numbers from 0 to 9, like one digit number, and there are 26 letters from A to Z. So in total, you got 36 choices, just 10 plus 26. Yeah, I'm sure you already know this, right? Something very simple like that. You also have something called the rule of product. This is the number of choosing an ordered pair from two sets or more. For example, if you have like two different sets, a set of character followed by a set of numbers, and you want to choose a character from the set of characters, you want to choose a number from the set of numbers, then the total number of combination you can have is the cardinality of the first set multiplied by the cardinality of the second set. So you're talking about A9, C5, Z3 and all that. For example, you got 26 letters, you got 10 numbers, you have 260 combinations. And how many two-digit numbers are there? Well, you got 10 options for the first digit, you got 10 options for the second digit. So you got 10 times 10, you got 100 combinations from 00 to 99. All right, starting slow, starting simple. Next up, permutation. So a permutation is just a number of ways that you can arrange the elements of a set so that they appear only once. For example, if I have the set ABC, then there are 6 ways I can arrange them. I can have ABC, ACB, BAC, BCA, CAB, or CBA. And the number of permutation of a set with n elements is just n factorial. Why? Because if you want to arrange them all, for the first character, you got n choices. For the second one, you got n minus 1 choices, and then n minus 2, and then n minus 3, and so on. Until eventually you only have one choice because there's only one element left, which you haven't picked yet. So obviously n times n minus 1 times n minus 2 dot 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 times 1 is just n factorial. Right? Now, if you don't want the permutation of all the elements in the set, right? If you just want a permutation of length k, so we call that k permutation, then for the first element you get n choices still. Second element you still have n minus 1 choices, but you only want k elements. So you gotta stop after you choosing k elements. So the formula for that is n times n minus 1 times dot 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 times n minus k plus 1, because that's the number of choices you have for the last element. And this is just n factorial divided by n minus k factorial. So you probably have seen this as NPR, like n permute r. All right, so that's permutation. Let's do some examples here of that one. If you got a set ABCD with 4 elements, how many permutation of 3 elements are there? Well, you got 4 choices for the first element, you got 3 choices for the second element, and you only got 2 choices for the last element. You don't have the 4th element, so you don't need to multiply that by 1, but doesn't make a difference anyway. But anyway, that means you got 4 times 3 times 2, which is 24 permutation, and I listed all of them down there. All right. And now from permutation, we move to combinations. So this time, if I have a set S, a combination is just a choice of unique elements without the order. So before, when we talk about permutations, you care about ABC, ACB, BCA, BAC, you care about the order, but we just want a combination of 3 elements. We don't care about the order. So ABC and ACB, they're the same. So we're just going to call it ABC. So for every combination of k elements, you have k factorial permutation, right? So if you just want the number combination of k elements, well, simply divide the number of permutations with k factorial. And that's the formula that you have down here, right? So with the permutation, you have n factorial divided by n minus k factorial. So to get the number of combinations, you just divide it by k factorial again. I mean, this is pretty much what happened before, right? But this is the permutation of 4 elements. So I got ABC, ACB, BAC, BCA, and that's just ABC. On the last row there, I got BCD, BDC, CBD, CDB, yeah, whatever. That's just BCD. So you get 24 different permutations, but only 4 different combinations. Okay. So also with combinations, you should have seen this thing called the Pascal triangle, which just tells you the number of combination. So if I look at the 5th line there, when the 1, 4, 6, 4, 1, the numbers on the Pascal triangle tells me how many combinations there are of size n. So if I want to take a combination of all 4 elements, so this is a set of size 4. So, and there's only one combination where I take all 4. There are 4 combinations where I take 3 of them, and there are 6 combinations where I take 2 at a time. And there are 4 combinations where I take 1 at a time, A, B, C, D. And there's only 1 combination where I take nothing, the empty set. Okay. So obviously also on the Pascal triangle, if you sum up all the numbers on the line, you cannot end up with powers of 2. Alright, so the 1, 4, 6, 4, 1, that's equal to 16. And the total number combination is always 2 to the n. Because for each item, you can either choose it or you don't choose it. Like I call this the light switch argument. So for example, with the line 1, 4, 6, 4, 1 there, if you have 4 choices, A, B, C, D, so each one of them you can either choose it or not choose it. Excuse me. So for example, AD corresponds to 1001 because I choose the first element and the last element. BCD corresponds to 0111 and so on. So how many combinations are there? Well, each bit representation corresponds to 1 combination. So you have 16 of them from 0000 to 1111 or just the power of 2. You also see these numbers when you're doing binomial expansion. So with the 1, 4, 6, 4, 1 there, you can see it on the last line there. If I do x plus y to the 4 and expand it, I'm going to get x to the 4 plus 4x cubed y plus 6x squared y squared and so on. So any binomial expansion, you just look at the Pascal triangle and you work out what the coefficients are. So that's all we need, permutation and combinations. So here's some examples that you can use to practice. If I got a set of numbers from 1 to up to 99, how many ways can I choose 3 numbers such that the sum is even? So you get 2 different cases here. The first case is that all the numbers are even, right? So how many ways can you choose that? It's going to be 49, choose 3, because there are 49 even numbers. Remember, you don't care about the order, right? You only care about 3 even numbers. And because there are 49 even numbers, well, it's 49, choose 3. So that's the first case, 49, choose 3. And you can also have the second case when you have 2 odd numbers and 1 even number, because that will also add up to an even number. And in this case, you got 50 choose 2 times 49. Why? Because there are 50 odd numbers, and then you're going to choose 2 of them, right? That's 50 choose 2. And then the other one is even, and you only have 49 choices. So 50 choose 2 times 49 gives you the total number of combinations that you have. And the total answer is going to be 49 choose 3 plus 49 times 50 choose 2. I have no idea what that is. It looks like a big number. You can compute it on the calculator. I'll leave that up to you. Now, the second example. If you have n guests on a circular dining table, how many ways can you seat them? We're gonna say that two arrangements are the same if one arrangement is just a rotation of the other one. So if the order is the same, we say that they're the same arrangement. Now, because we care about the order, then you know that this is going to be a permutation question, right? The answer is going to be n factorial. Actually, no, the answer is going to be n minus 1 factorial instead of n factorial. And you might be wondering why. Why is it n minus 1 factorial and not n factorial? Because you have n guests, so shouldn't it be just n factorial? Well, because the first guess that you place, it doesn't really matter where. Because these two arrangements, they're the same. Okay, so once you place one guess, that's kind of fixed. You only have like n minus 1 ways of doing the rest. I'll let you confirm this yourself, actually. You will notice that the first one that you place doesn't really matter. Only the remaining 4 that actually matters. Okay, so those are two very simple examples, and I'm going to do this in a very fast way because it's probably something that you already know and I don't want to be too boring. The most important takeaway really is just that you understand that the number of permutation is n factorial and the number of combination is 2 to the n. I mean, this is where we get O n factorial and O to the n. We're going to need this when we talk about brute force because, well, most of the time the number of combinations we have, the number of possible solutions we have is either n factorial or 2 to the n. Very often it's going to be 2 to the n. Okay, so that's pretty much all I want to say about permutation and combinations. Again, if you need more help on this, you can look at the textbook, Appendix C. You can go online somewhere. I'm sure there are lots of exercises you can do online. And yeah, but if you're okay with 2 to the n, if you're okay with n factorial, you should be mostly good. Alright, I'll see you in the next video.